and probabilities with independent events. Definition. Independent events. Two events are independent events if the occurrence of either of them has no effect on the probability of the other. So the formula is P of A and B, that's the probability of A and B, equals the probability of A times probability of B. Remember, we are using the word and now. Before we're using the word or, so that would be a plus, that's the operator, and refers to multiplication. So the dot symbol here means you multiply. And remember also that we're working on independent events. So there is also a condition when there is a dependent events. So independent and dependent. So here's the example. Okay. I'll give you a chance to read the problem. Let's look at what is being asked. What is the probability of red? So you're looking at red, so you should be taking this information, 18 are red. And it has 2 consecutive plays. So those are the keywords. So what we're doing here is finding the probability of red on 2 consecutive plays. So that would be probability of red and red equals probability of red times probability of red. And remember, we have 18 are red here, so that would be 18, and the total would be 38. That's 38 numbered slots. So that should be here times the same one, 18, because they are independent. So independent events. So we're going to have 18 are red again. So that would be 18 that we have to take over 38. And it seems that you can reduce the fractions here to multiply a smaller number. So we can divide this by 2 here, divide by 2, divide by 2 here, divide by 2 to have a smaller fraction. Okay. And we will have 9. 18 divided by 2 is 9. And then 32 divided by 2, that would be 19 times 9 over 19. Then you will have the answer, which is 81 over 19 times 19 is 361. So that would be the probability of red occurring on 2 consecutive plays. Okay, so if you want to change that into a decimal value, that is also correct. So you can say 81 divided by 361. And our answer in decimal form would be 0.22. And this is also right. Okay, that's 22% probability. Okay, so that's an example for and with independent events. Now let's look at and with dependent events. So definition here, we have dependent events. Two events are dependent events if the occurrence of one of them has an effect on the probability of the other. So this is the opposite because there is an effect here, the other one doesn't have an effect. Okay, so the formula here is similar. You still have to multiply because you're using the word and the probability, but remember B given that A has occurred. So it means that if A has occurred, it can affect the number of occurrences there. So going to the next event, most likely you have to subtract one. So that would be the case for that one. So let's have an example. Okay, so please read the problem and get all those important information. Okay, so the problem here, you have won a free trip to Madrid and can take two people with you. So let's take the number two people. All expenses paid. Bad news. 10 of your cousins, so we'll use that information, 10, have appeared out of nowhere and begging you to take them. You write each cousin's name on the card, place the card in a hat, and select one name. Then you select a second name without replacing the first. So here's the keyword, without replacing the first card. So you have to subtract one from the total of the first selection. If three of your cousins, if three of your 10 cousins speak Spanish, find the probability of selecting two Spanish speaking cousins. So you're looking at this probability, the two Spanish speaking cousins. Okay, so let's try that probability. Let's take the 3 also. We need that one. 3 of your 10. Okay, so that's 3 out of 10. So 3 over 10. So we'll take the probability. So the one that speaks Spanish, which is 3 over 10, times the probability, uh, you have speak Spanish here, given that Spanish cousin was selected first. So there is a condition here, given that a Spanish cousin was selected first. Okay, so we'll be subtracting 1 from actually 3 out of 10. So the probability that we can select two Spanish speaking cousins would be 3 over 10 because we have 3 out of 10 cousins that we can select, times for the second selection, remember it says without replacing the first card. So it means that we just have to subtract 1 for each. So since we have 3 out of 10 cousin speak Spanish, then we take 1 already, so that's -1. So you have to multiply it by 2 since we already selected 1. So we have to subtract. The total is 10 minus 1 should be 9. So the answer would be 6/90. Okay. And we can still reduce that. So I think 90 is divisible by 6, right? And you'll get 15 there. So you divide 6 on the top and divide 6 at the bottom. And then our answer would be 1/15. And that would be the probability of selecting 2 Spanish-speaking cousins. You can also express your answer in decimal form. 1 divided by 15, it will give you 0.07. So that would be also correct. And you can also say 7% probability. And that's how we address this problem. And remember, this is the opposite of what we did in the first. We have the dependent events. So if this is independent events, you're not subtracting 1 from the first choice. Okay, so that's the difference. Next, we have conditional probability. In definition, conditional probability, the probability of event assuming that the event A has already occurred is called conditional probability of B given A. This probability is denoted by, so we have a formula here. So that would be P plus probability B given A. So this is a vertical line symbolize the word given A. So that would be the conditional probability. Okay, so let's have an example. Okay, I'll give you a chance to read the word problem here. A letter is randomly selected from the letters of the English alphabet. Find the probability of selecting a vowel, given that the outcome is a letter that precedes H. So we have to have the sample space here. Our sample space is from A up to G, because that is precedes the letter H. So we have A, B, C, D, E, F, G. The next letter would be H. So it is precedes, so just up to G. So sample space A, B, C, D, E, F, G. Okay? Because of the word precedes, so we stop at G. So now, notice also that there's a word vowel. So the word vowel means you're looking at letter A and letter E. So we have 2 vowels. So that's actually the one over here, A and E. And then what's the question asked. The question asks, find the probability of selecting a vowel given the outcome is a letter that precedes H. So what you're doing here is you're going to actually find the probability with that condition. So it says P probability when you have a vowel, the vowel one, and then given letter precedes H. So that would be the letter that before the letter H. So you're looking at letters before that letter H. So that would be, if you count 1, 2, 3, 4, 5, 6, 7. 7 of those letters before H. So when you're taking that probability, you're taking the vowel, which is actually A, and there is another one which is E. So you have two of them, two vowels. So that should be 2 over the total. The total would be 7. You have 7 letters before letter H. So that would be your answer. Okay. And you can also express your answer in decimal form. So that would be 2 divided by 7. It gives you 0.286. Okay, so the decimal value is also acceptable for that answer. Or express your answer in fractional form to be exact. So that's conditional probability.